As we all know that automated question generation is crucial in education, which enhances critical thinking, active learning, and personalized education, but its evaluations remains a key challenge. Nowadays, automated evaluation metrics such as Bloy, Rouge, Meteor are being used to evaluate the generated questions which is created from the AQG systems. However, these matrices are typically used for machine translation or summarization tasks. Metrics like Bloy, Rouge, and Meteor focus on surface level similarity, neglecting deeper aspects of question quality such as relevance, engagement, and pedagogical value. While human judgment is essential for assessing nuanced qualities, it is quite expensive, time intensive, and impractical for large scale datasets. To address these challenges, we propose Mirror, which utilizes LLM feedback to improve alignment with human evaluation, enhancing key metrics, and boosting GPT-4's correlation with human judgments. As contributions, we first propose a novel method which is called Mirror. Mirror stands for Multi-LLM Iterative Review and Response for Optimized Rating. This feedback-based procedure involves prompting various large language models to generate scores based on human evaluation metrics, namely grammaticality, relevance, appropriateness, novelty, and complexity for the task of automated open-ended question generation. And we show that our proposed LLM feedback-based approach, which is called Mirror, provides score based on various human evaluation metrics, produces results closer to the human baseline compared to the direct prompting approach. And we also measure the Pearson's correlation coefficient between the GPT-4 generated scores and those of human evaluators, demonstrating that the feedback-based approach improves correlation compared to the direct approach for evaluating generated questions. For our experiments, we have used two existing datasets. One is the EduProbe dataset. From this dataset, we extracted 1,000 context and question pairs for several subjects like history, geography, economics, environmental studies, and science with gold standard question. And from the SciQ dataset, we extracted 500 context question pairs from physics, chemistry, biology, art science with questions crafted by the educator. And our methodology consists of 3 steps. First, we use the basic zero-shot prompting approach to generate the questions. And after that, we use the direct approach for evaluating the question quality. And after that, we used our proposed feedback-based approach, which is called Mirror, to evaluate the question quality. In our experiments, we used 3 state-of-the-art large language models, which are GPT-4, Gemini, and Llama 2 70 billion, to assess both direct and feedback-based approaches. So first, to generate the question via prompting. So here we use the zero-shot prompt, generate a question based on the following context, and the context is given. And in the figure, we can see that the question and the generated question pair from the EduProbe and SciQ dataset. And in the second step, we use the direct approach for evaluating the question quality. We can see from this algorithm that the input to this algorithm is the human evaluation metric definitions, questions, and its context, and the output is the scores for the several human evaluation metrics such as grammaticality, appropriateness, relevance, complexity, novelty. And the output is the scores. So here, the task is to compute scores for human evaluation metrics via LLM prompting, provided the given context, questions, and metrics. So in the left-hand side, we can see the overview of the direct prompting approach, where a prompt is fed to the LLM and the output is containing the scores corresponding to the question based on 5 matrices. And the prompt used in this direct approach is shown in the right-hand side figure. So here you can see that given the definition of the human evaluation metrics and the definition of 5 human evaluation metrics are given, and after that the context is given, and we ask the LLM to provide a score between 1 to 5 for the question based on the human evaluation metrics, namely grammaticality, appropriateness, relevance, complexity, and novelty, as well as the context corresponding to the question stated above. So here is our proposed method, which is called mirror, which is a feedback based approach for evaluating question quality. So in this algorithm, we can see that the input is human evaluation metric definitions, the initial strengths S0, flaw set F0, and the generated question to be evaluated and its corresponding context. And output is the converged scores for the questions. So initially, two sets are initialized, which is S0 and F0. Both sets are empty. And in the next step, we compute the scores for the question based on the predefined evaluation metrics. And from this assessment by LLM1, the first sets of strengths and flaws are identified, resulting in S1 and F1. And this process then enters an iterative loop designed to refine this initial assessment or scores. So in each iteration, we can see from this algorithm that the identified strengths and flaws, which are S1 and F1, are provided as feedback to the second LLM, which is LLM2. Along with this feedback, the human evaluation matrix, the question itself, and its context also provided. And LLM2 then generates a new scores for the evaluation matrix, updates the sets of strengths and flaws to S2 and F2, and this updated strengths from LLM2 are then also fed to LLM1. And then LLM1 again uses this information to re-evaluate the question, updating its scores and further refining the sets of strengths flaws to S3 and F3. And this process continues iteratively with each model using the feedback from the other to refine its evaluation until a convergence criteria is met. So once the convergence is achieved, the loop terminates and the final convergence scores and associated strengths flaws are considered the accurate evaluation of the questions. So this iterative process ensures that the evaluation is thorough and benefits from the complementary perspectives of two different LLMs, ultimately leading to a more reliable and nuanced assessment of the generated question from the EQG system. So here is an overview of the proposed approach called mirror. So in the left hand side, we can see a diagram which shows the our proposed algorithm, which is discussed earlier in the previous slide. So first you can see that there are two LLM1 and LLM2, and the prompt is given, and the prompt feed to the both LLM and LLM2 are shown in the right hand side figure. And the output of this LLM1 and LLM2 are iteratively actually feeding both LLM and LLM2 until the convergence is met. So to compare our proposed method to human educators, we also calculated the human baseline scores. For that purpose, we recruit 3 educators and ask them to evaluate the questions generated by prompting GPT 3.5 Turbo in terms of grammaticality, appropriateness, relevance, novelty, and complexity to generate the human baseline scores corresponding to EduProv and Psycho datasets. And the 3 educators were asked to provide scores for metric on a scale of 1 to 5. The scores given by the educators for each metric were then averaged. And I also calculated the inter-educator agreement, which is in terms of Felice Kappa. So we have seen that the inter-educator agreement between the 3 experts are 0.67, 0.64, 0.66, 0.45, and 0.59 for grammaticality, appropriateness, relevance, novelty, complexity, respectively. So here are the results. So table 1 shows the human evaluation results on the EduProv dataset for grammaticality, appropriateness, relevance, novelty, and complexity. And table 2 shows the human evaluation results on the Psycho dataset for grammaticality, appropriateness, relevance, novelty, and complexity. And we can see that from the table 1 that when we use feedback-based approach on EduProv, the scores of the large language models are closer to the human baseline. It means that when we use feedback-based approach, the performance of LLMs improving than the direct approach. And we can also see that GPT-4 outperforms other large language models, followed by Gemini and Llama 2 70 billion. And similarly, from the table 2, we can see that when we use feedback-based approach on the Psycho dataset, the scores of the large language models on several human evaluation metrics improves than the direct approach and is closer to the human baseline. Here also GPT-4 outperforms other large language models, followed by Gemini and Llama 2 70 billion. And here in this table 3, we calculated the Pearson correlation coefficient scores for the EduProbe and PsyQ dataset between the best performing large language model, which is GPT-4, and the human experts on these matrices. So you can see this from this table that when we use feedback-based approach using GPT-4, for both the datasets EduProbe and PsyQ, the correlation scores improves than the direct approach, which means that feedback-based approach is quite performing better than the direct approach and it is closer to the human baseline. And here are some examples of the output generated by LLMs using the feedback-based approach. So the left-hand side is the output by LLM1 on a subject called economics from the EduProbe dataset, and right-hand side is the output provided by the LLM2 on economics from the EduProbe dataset. So here the context is given and the generated question is what does purchasing power parity do? And on these questions, the LLM1 and LLM2 given scores, and after convergence, we can see the scores are quite identical in both the LLM and LLM1 and LLM2. Similarly, for the PsyQ dataset, so this is the examples on the PsyQ dataset. So left hand side is the output provided by the LLM1 on biology on PsyQ dataset, and the right hand side is the output provided by LLM2 from the biology subject on PsyQ dataset. Here also you can see that the scores provided by LLM1 and LLM2 after convergence are quite identical. So here the conclusion. So our proposed mirror system demonstrates the potential of LLMs as scalable and effective alternatives to human evaluation for open-ended questions in ecology systems. And by leveraging iterative feedback from large language models, mirror enhances Pearson's correlation coefficient between GPT-4 and human evaluation. Notably, the approach excels in improving metrics like relevance and appropriateness, which are critical for evaluating equity-generated questions. And in this work, we generally focused on the short to medium length context, and in the future, we look forward to handle longer context using our proposed algorithm mirror. Thank you.